So, you just landed your first role as a VLSI backend engineer? First off, congratulations. You're about to dive into this incredible world of super complex tools, massive chip designs, and yeah, some very, very long log files. But you've got a new secret weapon. We're going to break down how you can use large language models, or LLMs, to make your first project a whole lot less painful and a whole lot more successful.
We've all been there, right? You kick off a tool run, you come in the next morning, and it failed. You open that log file, and your screen is just flooded with a 10,000-line monster of warnings, errors, and messages. For a junior engineer trying to figure out where to even begin looking, it can feel totally overwhelming.
But what if you had a co-pilot who could just scan that entire log for you? Well, that's exactly where LLMs come in. These things are incredible accelerators. We're talking about debugging way faster by finding the root cause in seconds, not hours. We're talking about generating TTL scripts on the fly. And we're talking about having a knowledge assistant right there that can explain a complex timing concept instantly. The whole point is, this helps you iterate and get to closure so much faster. Okay, let's get into it. Before we even touch on the specific stages of the design flow, we have to cover the 3 golden rules. Getting this foundation right is everything. It's literally the difference between the LLM giving you a brilliant solution or just complete garbage.
Here they are. Number 1, always be specific. Context is king here. The LLM needs to know the process node, which EDA tool you're using, the specific corner you're looking at, and any key targets. Number 2, paste the raw logs. Don't try to explain the error yourself. Give the model the exact unfiltered output from the tool. It's surprisingly good at parsing it. And third, tell it what you want back. Ask for a TCL script, a numbered checklist, or a formal report. Be explicit.
All right, with those fundamentals locked in, let's walk through the back-end process step by step. We're going to start at the very beginning with prompts you can use in those early stages. Floor planning and placement. For floor planning, the technique to use is what I call context-rich prompting. The key is just loading it up with details. You're not asking some vague question. You have to include your die size, how many macros you have, maybe even some power intent from your UPF file. You need to specify the node and your utilization target. Only then do you ask for something like a macro placement strategy or even a starting floor plan TCL script. And this is a perfect illustration of that idea. Just look at this prompt. It starts by assigning a role. You are a PD engineer on 5 nanometer. It gives hard constraints, die size, macro count, a specific placement rule, and the utilization target. And then it makes a super specific request. Generate floor plan TCL for a novice. This is the kind of quality input that gets you a quality output. Now let's move on to placement and build on that. For placement issues, a really great technique is a few-shot approach using your violation data. What that really means is you're giving the LLM a real-world problem to chew on, like a nasty congestion report or a description of a routing hotspot, and then you ask it for smart advice on how to fix it. So, a prompt could look just like this. You literally paste in that ugly congestion report from your tool, and then you ask a really targeted question. See, you're not just saying, fix my congestion. You're asking it to think about a trade-off. Reduce the hotspots in a specific area, but without hurting my worst negative slack. You're asking it to think like a seasoned engineer. Okay, so our design is placed. Now for the really fun part, building the clock tree and actually routing everything. Let's look at the best prompting strategies for these super critical mid-stage tasks. When we're talking about clock tree synthesis, or CTS, the most effective technique is combining role assignment with really specific numeric targets. You're going to tell the LLM the exact skew budget in picoseconds, you'll define your clock domains, and you'll specify all those technical details, like the buffer library and any NDR rules. You're basically prepping the model to act like a CTS specialist. And here's that technique in action. The prompt kicks off with, act as a CTS engineer on 7 nanometer. Right away, that sets the persona. Then it feeds it the hard numbers for skew budget and clock frequency. It even gives a hint about the topology at once. A prompt this specific is way more likely to generate a useful, well-structured CTS spec file that you can actually use. Okay, on to routing, and listen. This is where you can save a ton of debug time. The go-to technique here is the error in, fix out pattern. It's super simple. You feed the LLM a raw error report like a DRC summary or a list of antenna violations, give it some key context like your metal stack, and then ask it for the root cause and a potential ECO fix. And this is what that looks like in the real world. You just paste the log and ask the LLM to do 2 things for you. First, organize the chaos by classifying the violations. And second, give you actionable solutions for a specific problem. This takes a scary, messy log file and transforms it into a prioritized to-do list. That is an absolute game changer. All right, let's bring it home. We're in the home stretch now, the most critical phase of the project, closing timing and getting ready for final sign-off. The pressure is on, which means our prompts need to be super precise. For a really complex task like analyzing a critical timing path, we need a more advanced technique. This is where chain of thought prompting is just fantastic. You paste in a full path report from primetime, you give it all the context about the corner and your targets, and then, this is the important part, you explicitly ask the model to analyze that path step by step. The magic phrase is right there at the beginning. Think step by step. This simple instruction forces the LLM to break down the problem logically, just like a senior engineer would. It will actually deconstruct the path, pinpoint the biggest slack killers, and then suggest ECO options ranked by their potential risk. This is how you get deep, insightful analysis instead of a generic answer. And finally, sign off. At this stage, it's all about process, it's about being repeatable, and it's about eliminating mistakes. So the technique here is structured output prompting. You're not really asking for creative ideas anymore. You're asking the LLM to generate a reliable tool for you, like a checklist or a run script, based on the exact checks, PDK, and tool you're using. This prompt is a perfect example of building a sign-off utility. By asking for a checklist that's formatted as numbered items with specific columns, you get a clean, easy-to-follow document that makes sure no steps are missed. It basically turns the LLM into a powerful process automation assistant. So we've walked through the entire back-end flow, from floor planning all the way to sign-off. Now let's just zoom out for a second and pull all of these techniques together into a universal toolkit that you can use for pretty much any task you come across. Think of this as your personal cheat sheet. Each row gives you a repeatable pattern you can use. Need to fix DRCs? Paste the summary and ask for a table of fixes. Debugging timing? Paste the path report and ask for a numbered list of ECOs. These templates are your go-to starting point for almost any problem. Okay, now this is probably the most important slide in this entire explainer. The do's are our best practices. Be specific. Use raw data. Ask for structure. But the don'ts are absolutely critical. Don't ask vague questions. Don't just blindly apply suggestions without verifying them yourself. And the big one, the most important rule of all, never, and I mean ever, paste proprietary IP or any data covered by an NDA into a public LLM. Always, always, always check your company's AI usage policy first. So, if there's one thing you take away from all of this, let it be this. An LLM is an incredibly powerful co-pilot. It can help you navigate, it can spot problems faster, and it can suggest different routes to take. But it is not an autopilot. You are still the pilot. You're the engineer in charge, and you are always responsible for making those final, validated decisions. And that's a wrap. You have the rules, you have the techniques for every stage of the flow, and you've got the templates to get started. So the only question left is, which one of those EDA logs sitting on your desktop right now are you going to analyze first?